Okay, the first thing I want to talk about now that you have your momentum packets out is what's going on this week. So, if you take a look at the board over there, today we're going to talk about momentum and impulse. And then tomorrow we're actually going to do an egg drop. And the egg drop is going to be you tomorrow in the first 20 minutes of class are going to create like a landing pad for your egg to fall. And what we're going for is really just getting the egg to not break after it's fallen for 1 meter. Okay. And then you are going to earn like some bonus points if you can get it to fall farther than 2 meters or even 3 meters. And 3 meters is about 6 feet. So it's not like we're going to the backside of the stadium to drop the egg off. That is not what we are doing. But we're going to do just a little egg drop and hopefully have a little bit of fun tomorrow. Then on Wednesday, we are going to do a summative CER on which car seat is the safest. And so that's a claims evidence reasoning. And that one's going to be summative. And I think it's only 15 points. Then on Thursday, we're going to review all day for the test over force and motion. Then Friday, we're going to take the test over force and motion. So that will be over speed and velocity and acceleration and displacement and distance and Newton's first law and Newton's second law and Newton's third law. Like all of that is going to be involved in momentum. All of that is going to be in the test. And it's mostly going to be vocabulary words, which is why on the screen here, I put whole unit, force and motion, and this is the Quizlet. Okay. All right. So now today, would you get out your momentum paper and let's just review a couple things about your video that you watched. It looks like you guys got a little bit farther than my morning classes. I think Mr. Dalton kind of figured out that he had to slow the video down so that you could get all the answers in there. Yep, so you're good to go there. So let's just take a look and talk about maybe the most important things. The first thing that was talked about was Newton's first law. So if you are not seat belted into a car, the chances of you becoming the object that stays in motion are 100%. So if you've ever panic braked in your car, you see something and you brake real hard, you feel your seatbelt lock in, right? Okay. So that is you being kind of locked in by your seatbelt so that you don't become the object that stays in motion. Now, the thing that we're trying to solve in our egg drop for tomorrow is not necessarily force, but what we're trying to solve is the word called impulse. So impulse is force and time. Now, do you remember in the example in the video where he threw an egg against a brick wall and it splatted? And then he threw an egg against a sheet that was around that brick wall and it didn't splat? Do you remember that? Okay. The reason that it didn't splat is because of the word impulse. Throwing that egg against the sheet, basically what it did was it allowed the force to be absorbed over more time. So now, kind of like a seatbelt locks you in and keeps you from becoming an object in motion, what a airbag does is kind of absorb that force for you. It slows you down, or whatever object is in the way, it slows you down so that you are being absorbed by that side airbag or the front airbag or whatever. Now, we could have talks about the force at which the airbag comes out that can sometimes be problematic. But for the most part, the purpose of a airbag is to increase your impulse. Okay. Soccer kicks and slap shots and egg toss. We talked about that. Crashing and smashing. crumple zones, airbags, and breakaway light poles. Have you ever seen those big yellow containers on the side of like exit ramps before that kind of interrupt the exit ramp in the regular freeway? And those are either filled with, like in Iowa, they're probably filled with sand. In other places that don't freeze, they're probably filled with water. So that when you crash into those, they're kind of like these, like just little crash objects that are going to slow you down before you hit something really important. Okay. Now, we're going to talk a little bit about potential and kinetic energy. Potential energy is what kind of energy? Do you know? What kind? Yeah. Potential energy is like stored. You're not moving. Kinetic energy is in motion. Okay. All right. So now, today we're going to talk a little bit about impulse. So would you flip your packet to, it's a worksheet and it is titled Egg Simulation, maybe? Egg drop interactions, is that what it's called? Egg drop, yeah, the questions, egg drop interactive. And you're going to have to get your computer out. And if you need to plug in, you know, just walk around the room, find a place to plug in. I don't think so. Now, when you get your computers out, you're going to go to this egg drop interactive simulation. And I am going to give you 15 minutes to answer those 14 questions. So you're just going to go through the simulation, and it's really kind of a critical thinking activity on force, momentum, and impulse. So if I gave you 15 minutes, that would put us at about 1:40. I'm going to stop you at about 1:40. All right. So that gave you about 15 minutes. And what I'm just going to call that is like your research. And that's your research for how you're going to keep your eggs safe when you go to build your contraption tomorrow, which we're just going to call a landing pad. So this is maybe, oh, you can close your computer screens. You don't need those. This is maybe a little bit different from what you've done in the past. Because you're not attaching anything to the egg itself. You're going to let the egg fall on its own, but it has to land on something that is going to increase the impulse. So we're going to increase the force because we're going to drop it from 1 meter and 1.5 and 2 and 2.5 and maybe 3 if we make it. Okay. So we're increasing the force, but how can you make something that's going to absorb that force and take it longer so that it can still survive? So let's go through some of these questions here. Number 1, when a small egg is dropped onto a piece of 1-inch foam, from which height did the egg break entirely? What do you got? You should have D. Nonsense. The small egg never broke when dropped onto 1-inch foam. Number 2, when a small egg is dropped onto a piece of 1-inch foam, which height did the egg fracture but not break? Now, I had C, when dropped from 10 meters. It fractured, but it didn't break. So you should have C. Number 3, when a large egg is dropped from a height of 10 meters, upon which landing surface did the egg break entirely? Yeah, I had both A and B for that one. Number 4, how do the 3 surfaces compare in terms of providing the eggs with a safe landing? And what they're asking you to do is to go from least safe to most safe. You should have B. The hard floor is the least safe, then the 1-inch foam, then the foam box. Number 5, which statement describes the effect of increasing drop height upon the force encountered by the egg? Now, if you look at these, you'll see that they're lettered off. So what you should have picked is A, even though it's the second choice. Okay, number 6, trials with which two set of experimental conditions would allow an experimenter to determine the effect of increasing drop height upon the force experienced by the egg. You should have picked 2, A and E. Yep, A and E. So what you want to keep the same would be the same size egg. You want to change the drop height, and you want to keep the surface the same. That's like an experimental design. Number 7, 2 trials were conducted with these conditions. What could be the purpose of these 2 trials? You should have C, to determine the effective mass of an egg upon the force it experiences. Number 8, when a jumbo egg was dropped from 5 meters into a 1-inch foam surface, it fractured. Which of the following changes in condition would lead to a safe landing? What do you got? Yep. A, B, and E? Yes, A, B, and E. Number 9, which of the following variations would increase the force experienced by the egg upon the landing? What do you got? A, C, and E. Yes. Number 10, when a large egg was dropped from 5 meters into or onto a 1-inch foam surface, it landed safely. Which changes in condition would lead to a fractured or a broken egg? What do you have? B, C, F. Yes, you should have B, C, and F. Now you should be on page 3. So number 11, which set of experimental conditions would result in the least amount of force on an egg? If you picked A and D because they were the same ones, that's right. All right, number 12, which set of experimental conditions would result in the most amount of force on an egg? D. Just D. Number 13, what effect does doubling the mass of an egg have upon the force of the egg experience? A, doubling the mass makes the force twice as large. And then number 14, which of the following questions cannot be answered by the egg drop interactive? A, yep, it's rebounding. We don't really talk about rebounding. It's like the bouncing off, kind of like when we did inelastic collisions and they were kind of bouncing, those balls were like bouncing off of each other. Okay. All right, so now how about this? How about if you flip to the next page? Are those the directions? Okay, so let's go over the directions for tomorrow. Give me a minute here. Before you get too excited, I want to go through the directions so that you know kind of what we're looking at here. Oh, when you did your momentum bashing on Friday, what did you find? The more marbles, what happened? Yep, the more marbles, the more the cup moved back. Okay. So here are the rules for the egg drop tomorrow. Would you put your phone away? It's supposed to be in your backpack anyway. Thank you. All right, so groups may use less, but no more than 10 sheets of paper. Now, you are going to have to tell me how many pieces of paper you're going to use. And the reason for that is because if there's a tie, like if we get to dropping it from 3 meters and there are 2 eggs that survive, I will apply the winner, right? The one who gets the most points to the people who use the least amount of paper. So there will be a bonus for not using a lot of paper. Now, the collision safety device must be freestanding, so you cannot tape it to anything else. You can attach anything to the egg. So I've heard that you've done this before, only you attach stuff to the egg. You can't attach stuff to the egg this time. You have to make a device that is freestanding, meaning it sits on the floor, and when your egg falls into it, it absorbs the impulse. Like it creates like an absorption of, oh, it's not going to break because it's going to have time to fall. Scissors may not be part of the collision safety device. The dropping height is going to be measured from the bottom of the egg to the top of the safety device. Eggs will be dropped by you guys, not me. I've done that before. I get blamed for a lot of things. I can't handle the pressure. Okay. Eggs that miss the collision safety device when dropped are eliminated. So if you miss the collision safety device and it just drops on the ground, sorry about it. Eggs will be inspected before and after each drop, and they must not show any cracks. Eggs that survive the initial impact but roll off their device and break are eliminated. Teams that break their eggs by accident or carelessness are eliminated. And in order to simulate car collisions with greater momentum, the eggs will be dropped from successively greater heights. So we'll start at 1 meter, then we'll go to 1.5, then we'll go to 2, then we'll go to 2.5. And tomorrow you're going to get 20 minutes to build them. You have to have it built in 20 minutes, and then we'll test the last 20 minutes. Now, what are we playing for? Well, I mean, maybe money, maybe candy, but no, here's what we're playing for. If it makes it 1 meter, you will pass, meaning you will get the formative points of 20 points because you made something that made it 1 meter. If it doesn't make it 1 meter, you will only get 10 out of 20 formative points. Okay? Now, if your egg makes it 2 meters, so it lives past 2 meters, you will get a little card that says you've earned 3 points to add to your summative assessment that you can add to your summative assessment on Friday. Okay? If it makes it 3 meters, you will get a little card that says, I just made an egg device that made it 3 meters, and you will get to use 5 points on your summative assessment. And you can just staple it straight to the summative assessment, and I will add that to your test. Okay? Now, I did give you a little help here in terms of maybe how to make an egg landing pad. There are some examples that you could probably look at that I left you here. Now, here's what I'd suggest for the rest of today. You are going to go to this next page. And I would say in the next 5 minutes or so, you should draw a diagram of what you want your landing pad to look like. Now, tomorrow you're going to need a partner. So you guys can work together right now if you want to, but you're going to need a description of a landing pad, what you want where, and you're going to need a diagram of it. And then we'll build tomorrow. How many pieces of paper do you get? 10. That's it. And tape and scissors.